So before I do anything in this video, I want to first make very clear that there may be an off chance that this video is a bit outdated from the notes I give you in class because I'm making these before I print anything out. So if they're not identical, don't freak out. The ideas that I'm going to illustrate here are still the same throughout all of math. Doesn't matter what class you take, doesn't matter what packet I give you, they're still the same. But just be aware they may be different. So in these first 6 examples, I actually wanted you guys to figure out 2 possible x values that when you square them will give you 9. So if you haven't done that, I would suggest you guys do that now. But here, 2 values are 3, and the other one, -3. Because 3 squared gives you 9, and -3 squared also gives you 9. Here, again, a positive and negative version. Here, this one again. For those that don't know how to do the fraction one, they're still the same concept. But the only difference is you're applying it to both the numerator and denominator. So here, 4 squared is going to give you 16, and 3 squared is going to give you 9. The bottom one, same thing. And the last one has no real solutions. The reason is because no 2 numbers squared here is going to give you it's going to give you -4. If you try 2 squared, that's going to give you +4, not -4. And if you try -2 squared, that's going to give you +4, not -4. So this one here, when it's equal to a negative number, no real solutions. However, that is still solvable, just not with what you know. So be aware, this we will come back to later. In question number 2, I ask you guys, what did you notice about what you saw up here? You guys should have said a positive and negative answer for all the problems except for letter F. In question 1, what key calculator could you use to help you solve the equation? The answer is the square root key. So for example, if I wanted to find the solution that give you 9, all you need to do is press the square root key to give you 3. And then remember the negative version. Here you're going to done square root of 36, you're going to square root of 25. Here you could have even done the square root of 16 over 9, which would have given you 4/3, or 1.3 repeating, and same thing with E. Based on what you know, explain how you can solve this one without guessing. So here, if I wanted to find what's going to go in for x, I would just square root 5.76, that's it. And I would account for the positive and negative version of that. Now, if you look down here, I have a nice little box here for you guys. It's the square root property, and this is all it says, okay? Read this yourself, but this is all it says. When you square root a number here, for example, 25, so whenever we square root a number, in reality, we actually have 2 solutions. We have one that's positive and one that's negative. And again, the reason why is because if you square this will get you 25, and if you square this, it'll also get you 25. So keep that in mind. We have a positive and a negative version. In these examples, I'm going to do a couple of them, but then I want you guys to try. Ideally, I would like you to try number 2 here all by yourselves after I try these ones up here. The goal is still the same. You're going to get x by itself. But in order to do so, you have to make sure you get rid of the squares that are in all of these problems. So in problem A, it's very easy. To get the x by itself here, you're just going to subtract 5 to both sides. Now, here's the trick. X is still not by itself here. It has to squared. Now, the opposite of a square is a square root. So if you want to cancel this out, you just square root both sides. These cancel out. And you're left with 0 and -0. But -0 is the same thing as 0, so we just write this one once. Letter B, same concept. Here, you're going to add 25 to both sides. And if you look at this, you still see the square, but you see a 4 in front of the x squared. So that 4 is what you're going to get rid of to the other side first, because it's very easy. You just divide both sides by that. And one last step, you're going to square root this. Now when you square root it, you have plus or minus. Oh, we didn't talk about plus or minus. This just means a positive version and negative version. That's all that means. But you have plus and minus 5 divided by 2, or if you plugged in a calculator, 2.5. Letter C. And this one's unique. You can't square root a negative number yet, so this one has no real solutions. You'll actually find out this one does have an answer. It's just you don't know the number system in which the answer actually exists. So it's a bit of an odd play. Okay, D through F is where things get a little bit trickier. I'm going to try D here, then afterwards I would like you to try E and F because they're very similar. Now, the temptation here is going to be to subtract 2 from both sides. You're not going to do that. And here's the reason why. That 2 is locked inside of the squared. So before you get rid of the 2, you need to get rid of that squared. Now, if you remember, the opposite of a square is a square root. So that's what you're going to do here. So you're going to square root both sides. These cancel out. And the square root of 9 is positive 3 and negative 3. So, just like with the absolute value, you're going to end up with 2 versions of an answer here. Because when you square root, you have a positive version and a negative version you have to account for. So you're going to have 2 answers. This one and this one. E and F, try those out. If you guys want a little bit of guidance, I'll do it right now. Positive 4 and negative 4. Again, make note, the only signs that change are what was square rooted. In this case, the 16 was the only one that was really square rooted without being canceled. So that's what's going to have a positive and a negative version. Letter F, same thing. Square root of 1 is just 1, guys. A couple of students, always a student or two that seems to be confused by that. Square root of 1 is just 1. There's no trick to it. Okay, these bottom ones. Pause the video and give them a shot. Once you're ready, unpause and I will do the answers with you guys. I subtracted 80. Then I divided by 2. And then I square rooted 40. I don't know what the square root of 40 is off the top of my head, so I'm going to leave it like that. It isn't perfect, I can tell you that much. Divide by 3. And then square root, and you have plus and minus square root of 3. Add 90, square root this. And again, square root of 90 is not perfect. You're going to get some decimal. Add 64. Divide by 2. Square root. Again, some wild decimal. Here, fun stuff. E and F are going to be a bit trickier. You are going to square root, but first, you want to move everything over to the other side as fast as you can. This 4 outside, you can move over here. You can move that 4 over by taking a wild guess. What you're going to do, you're going to divide by 4. Cancels out. 0.25? Yeah, 0.25. Square root both sides. And 0.25 gives you 0.5 and gives you negative 0.5. From here, you're going to add to both sides. If you didn't know how to do F, but you think you know how to do it now after seeing letter E, pause the video and give it a shot yourself, okay? Again, divide by 2. And then you're going to square root both sides. Square root of 6 should be 2.449. A positive and a negative 2.449. After that, you're just going to add 3 to both sides. And then add that to both sides, which should get you negative 0.550. No, positive. Positive 0.55. This example is actually a real-life word problem. I just kind of threw it on there because I'm a fan of physics, and it would be great if we had more time to discuss physics with math, but we don't. If you guys want, try this out. I'm just going to do it really quickly right now to show you guys how it looks, but it's not that difficult. So in this example, you're rolling a ball down a ramp, and this equation here measures how far the ball is here at some time t. So part A asks you, explain why it's a quadratic. It's a quadratic because it has an exponent 2. Because it's exponent 2. That is not good grammar. That's not. You guys get the idea. In the equation, guess what 4 represents? 4 represents the initial height of the ball. And here's what I mean by that. To find the initial height, up here, when you start your timer, you don't start at 1 second, you start at 0 seconds. So at 0 seconds, if you plug it into here, you're just going to get a height of 4. Well, the 4 here represents the initial height, where the ball starts from. C and D is really where the math is going to be involved. When does the ball reach the floor? What does H equal? Well, when the ball is down here, what is the height? The height is 0. Do we know how long it takes for it to reach there? We don't yet, but that's what we're going to find, because that's in part D. So to find out how far this, or how long it took for the ball to go down the hill, we're going to solve this equation where H is 0. And then we're going to square root both sides. But only one of these solutions makes sense. Either the positive 0.5 or the negative 0.5. Take a wild guess which one it is. Obviously the positive, because you can't have negative time. This is called an extraneous solution, and it's a bit hard to explain where it comes from. I certainly can on a one-on-one basis, but in the video I'm not going to try. It's just going to confuse too many kids. But you don't need to know the reason why this makes sense. Just be a nice little tidbit. The extra ticket, guys, please give these a shot yourselves. Same with these problem sets. These are your homework. Try these out. If you have any questions, feel free to contact me. You know what? I'll do the extra ticket right now. Pause the video and give it a shot yourself, but I'll show you the answer. I'm doing a lot of the mental math here, which after a couple of practice, some of you guys will definitely be able to do, so I encourage that. Just be careful with your mental math. Try these out yourselves. For letter B, H, I don't know why I call this B, H, my recommendation is going to be this. Try to move everything outside the squared to the other side. So move the 20 over here, then move the -2 over there, and then solve the regular way.